Here we have another detailed reasoning question. So you try not to use a calculator in this question and just write down all your working. It needs to flow logically. Part 1 asks us where it crosses the x-axis, that's where y is 0. So set y to be 0. That gives us 0 equals ln x over x, so therefore 0 equals ln x, which gives us x equals 1. Dead easy 2 marks. Question 2. Points A and B lie on the curve and we're given the x coordinates. Show that AB is horizontal. In other words, show that for those two x coordinates we get the same y coordinate. Well, if you stick x in as 2, you get y is ln 2 over 2. And if you stick in x is 4, you get y is ln 4 over 4. Now, candidates who reach for their calculator a little bit too easily here and calculate that both of those y values are roughly 0.35 and writing that down, just don't get these marks, I'm afraid. That's not showing detailed reasoning. So you just need to show that ln 4 over 4 simplifies to ln 2 over 2. So using your laws of logs, ln 4 over 4 is ln of 2 squared over 4, which is 2 ln 2 over 4, which is 1 ln 2 over 2. So just a little sentence to conclude and say y coordinates are equal, so they're parallel. Or so that AB is parallel to the x-axis. Part 3, find the turning point on the curve. So, we know what to do for a turning point. It's quite a nice question, this. The algebra is not simple, but it guides you through. There's no mystery about what you need to do, really. Turning point to differentiate, but differentiating this you need the quotient rule. So I haven't shown all my working here for the quotient rule, but you should if you can't do quotient rule in your head. If you can do it in your head, then it's sufficient to write this down. The formula's in the formula book, but what I do, I just know it because I know that you need to do the denominator times the derivative of the numerator, so that's x times 1 over x, minus the numerator times the derivative of the denominator, so subtract ln x times 1. And it's divided by v squared, so denominator squared. You'd be a fool not to simplify that before using it. And then we're trying to find a turning point, so set it equal to 0. Ignore the denominator. Solve that for x, and we get x equals e. So our coordinates, because it does ask for coordinates, not just the x value, we need to substitute e in here, so ln e divided by e. Ln e is 1, so the coordinates are e, 1 over e. Determine whether this turning point is a maximum or minimum for part 4. Well, sorry to say it, guys, but you're going to need to differentiate again using quotient rule again, but with this more complicated expression here. So this is how I think about this. D squared y dx squared is going to be denominator times the derivative of the numerator. So x squared times minus 1 over x, if we differentiate the numerator. Subtract the numerator times the derivative of the denominator. You can check yourself whether you think you agree with that. And again, divided by the denominator squared, which now is x to the power 4. And again, I think you'd be a fool not to simplify that numerator. X squared times minus 1 over x is just minus x. And then you've got another minus 2x from here, so that makes minus 3x. And actually it simplifies further because you spot that every single term has got an x in, and we can cancel those x's, not the one after the learn line. And we've got that as a simplified second derivative. So just to finish off, substitute in your value of x, e. So when x equals e, second derivative equals and it simplifies to minus 1 over the cube of e, and that's negative, just write down, because it's detailed reasoning, remember, don't forget. Minus 1 over e cubed is negative, so it's a maximum.